Polynomials. I'm really a big fan of this section. I think that there's a lot of cool ways that we can evaluate polynomials when there's any number that's given to us. So eventually we could see that if we had a crazy polynomial like 3x to the fourth, adding on 3x cubed plus 7x squared, a really wild number. Let's deduct 2x here and then plus 1. We could eventually try to see what this outcome would be if we were checking where x is, I don't know, really any number. If we wanted to check, we could do something like -10. And we could find this outcome without using a calculator, without plugging in and evaluating, all right, -10 cubed or to the fourth power or squared. And this is really tying into how we divide with polynomials. But before we see how this is all done, we'll see synthetic division and the normal division of polynomials, which should look familiar to how you've used long division in the past, where you've had some number inside under this root. You've had some number that you keep trying to think out, all right, well, what number would get this higher and higher and closer to the number so that you can cancel out a lot of this. We see the same idea here for polynomial long division, where we're trying to match the very first term that we see. We see that 2x times 3x would get us 6x squared. We then distribute this to both of the terms or any terms over here for the quotient. And we eventually try to end up with the remainder of 0, but that doesn't always happen. So with the example seen here, we see that 2x plus 1 when multiplied with 3x plus 2 would give us 6x squared plus 7x plus 2. What's cool about this is that we're not using factoring. So I think this is kind of a really cool section. And we'll see this from the first example. I believe that the synthetic way is going to be something that I'm more gravitated to because it's quicker, which is always something that's good. Snap for that, snap for easy stuff. As we take a look at polynomial long division, this takes a little bit more time, but I think it's really important to know how this works because eventually with synthetic we'll crush this, but it's nice to see the process. So how this will set up, since we're trying to divide 5x squared plus 2x plus 3, we'll set this up like a division problem where on the outside we have x plus 1. And so this looks like it's intimidating. Division, it can be tricky. You can think of it like fractions, but let's take this one step at a time. So the very first question I'm asking is, what would I have to multiply x by, because x is the first term that's here. So what to multiply x by to get our very first term here, 5x squared. And I'll try to color coordinate on this a little bit. So I'm trying to think, what would I multiply this x by to eventually achieve 5x squared? Because we want to try and cancel these out. I'll give you a moment to think that out. What times x would get us 5x squared? So hopefully you're saying 5x. And since this is just 5x, I'm going to leave this over the 2x because I try to line up my exponents so that they're lined up and I don't have to rewrite anything. It would seem kind of odd to have 5x over this 5x squared. So I know that 5x is what I'm looking for. And so now my objective is to try and distribute 5x to x plus 1 because we're trying to eliminate everything that's in here. And so how we do that is always by subtracting the product of 5x and x plus 1. So I know that 5x times x gets us 5x squared. So we'll throw that in here. And keep in mind that I'm also distributing 5x to this 1. So I would also want to add on 5x. And this is where we start to combine like terms if possible, or add and subtract like terms. So I know that 5x squared minus 5x squared would cancel. So we have nothing here. This is over. If we have 2x minus 5x, we get negative 3x. And 3 looks a little lonely. Look at it. It's got nothing below it. Nobody's hanging out with it. Nobody's talking to it. So let's just bring that down. Okay, well, we've gotten through one step. Congratulations if you're still with me. If you're a little stuck on what I just did, think about the question that I asked, think about what I did here, and keep in mind that we're always subtracting as we begin to distribute this top number here, or top term, and start to deduct everything below it. So you're always subtracting. And this is really important because some terms in here might be negative. Think of it eventually as subtracting a negative term. And we'll see if that comes up with these examples. So we know that 5x times x would get us here. Now the question we're asking is, for this step, what to multiply the green x, yeah, still that x by to get this negative 3x, because now this is the polynomial we want to eliminate. Hopefully you're saying negative 3, so let's write in negative 3 here. If we distribute negative 3 to these two terms, keeping in mind that we're subtracting everything, negative 3 times x gets us negative 3x. This might be alarming to see that you're subtracting a negative term, but this is actually what you want because you want this term to cancel. So keep that in mind. We also will multiply negative 3 with this 1. Think of it like distribution. If we have negative 3x and we're subtracting negative 3x, think of this as addition, which is what we wanted. We want to cancel this. So this is gone. We also have 3 and we're subtracting negative 3. So this is actually adding on, which would leave us with 6. And so we're kind of stuck on this problem in the sense that there's not much we can do to multiply this x term again to get 6. So in a similar long division fashion, we say that 6 is our remainder. And our answer would be 5x minus 3. So collectively for this, 5x minus 3 is our quotient, meaning that if we multiplied 5x minus 3 with x plus 1, we would get awfully close to this, but we're off by 6. So we say that if we multiplied all of this and added on 6, that would get us back to the original polynomial 5x squared plus 2x plus 3. I'll give you a moment to try the next one. So pause that, give it a shot. I'll kind of do a speed run for it real quick. So notice that I'm going to run through this pretty quickly, but I'm kind of asking the same questions I would here. So I'm asking myself, what times x gets us 3x squared? That would definitely be 3 times x. So we're deducting 3x squared, because 3x times x gets us 3x squared. We're also deducting 21x. Negative 29x, subtracting negative 21x would get us negative 8x. Bring it down, 56, there it is. What times x gets us negative 8x would be negative 8. We're then subtracting negative 8x. Negative 7 multiplying with negative 8 would then add on 56. Gets your kicks on root 56. I don't know if that's actually a geographic route, but similar to Route 66. It's a long highway that goes a long distance in the US. Subtracting what we have here, x cancels, that's done. I like to draw a frown face because I know that I canceled the term, and this is always your goal for the very first term you're working with. 56 subtracting 56 leaves us with nothing. I'll actually have that kind of face here. So notice that we have no remainder, which is fine. So we can say on the side here that our quotient is 3x minus 8. And there's a remainder of 0, or there's no remainder. What a shame. If you get stuck on this, rewind, ask questions in class. If you're stuck, we'll see more and a more convenient way to do this with synthetic division in a moment.